Okay, students, on page 109, they discuss for us the reactions in litmus milk. Now, I just want to go through this overview with you on page 109. They say milk is a very good medium for bacteria, but also used extensively for biochemical characterization and the identification of organisms. Why are we doing all these tests? We want to identify organisms. One organism can be starch positive, glucose fermentation, acid and gas, litmus milk, these reactions, MRVP, those reactions. So everyone is different from each other, and so we can use it for identification of organisms. They say protein and carbohydrate substrates, primarily casein and lactose. Casein is a protein, lactose is a carbohydrate, respectively are contained in dried skim milk. And microbial degradation, or either of both, can be detected. The addition of litmus to the milk provides an indicator of the organism's ability to produce an acid or an alkaline, as well as its oxidation reduction. Oxidation reduction activities, we've done it also in the fermentation of carbohydrates. Therefore, they say this litmus milk can provide much information on microbial reactions, and it's used to characterize bacteria, especially those ones that we do not know how to that is unknown to us. Okay, now I'm coming to, they say that litmus is a substance extracted from the genera Leonora or Rosella and consists of phenol-containing compounds. And litmus consists of a phenol-containing compound, but there may be some other compounds inside there that we do not know exactly what is litmus containing. But what we know, it's a very good pH indicator. And this litmus is a light blue grayish color at a pH of 7, pink at a pH below 5, and blue or violet above a pH of 8. Now, after we incubate it, after autoclaving, the pH roughly of milk is about 6,8. Now, this is a broth. It's a liquid, and we add into that litmus milk. All right. And then they say that litmus is also an oxidation reduction indicator. When the oxidation reduction potential of the medium is lowered by oxygen that's been removed by the bacteria, litmus become colorless. What other stain did I say in anaerobic culturing can we use as an indicator to see if the anaerobic jar was under anaerobic conditions? Yes, methylene blue. Methylene blue is a stain that we use generally every day in a microbiology lab. But nice blue color, but under the anaerobic conditions, it's colorless. The same with litmus. Litmus under anaerobic conditions is also colorless. So the milk will become white again. All right. Now, I want you to know these different things that we can read in this litmus milk. First, lactose fermentation. Some organisms are capable of using this lactose, that's a sugar, for energy production and employs the enzyme beta-galactosidase to break down lactose, and it breaks it down to glucose and galactose. Why will the bacteria do it? Because it's easier for the bacteria to take up the glucose and the galactose, and it's not so easy for him to take up the lactose. Now what are they doing with the glucose? They push it through the glycolysis process, and they're producing pyruvic acid, and from the pyruvic acid, lactic acid, butyric acid, CO2, and hydrogen gas. I expect from you to know what is beta-galactosidase, why are the bacteria using this beta-galactosidase, all these reactions around it. Now, in this case, you can see there's a lot of acids being excreted. Pyruvic acid, lactic acid, butyric acid. What does it do? Affect the casein that exists as large molecules in colloidal suspension, giving the milk its white turbid appearance, and in the presence of sufficient acid, the casein becomes a curd. What happens with milk if we put in vinegar or lemon juice? It becomes thick. The same here, because the bacteria is producing acids from the lactose, it becomes thick, and we call it a curd. Okay. The end products of lactose fermentation may include the gases carbon dioxide, hydrogen, and so on. And in litmus, the production of such gases may be evidenced by the breaks inside, because it's now, the curd is quite thick. You will see breaks inside this milk, and that is the gases, and that's an indication of CO2 gas and hydrogen gas that's been produced. Right, what is renin production? Renin production, and I ask this in every exam. Curd formation can also come about by the action of the enzyme renin, produced by some bacteria. Renin acts on casein to form paracasein, which is then converted to calcium paracaseinate and forms a curd through a process being called sweet curdling. The rennet curd is a soft semi-solid clot that will flow slowly when the tube is being slanted. So when we take the tube and we slant it, it will flow very slowly. This renin production plays a very important role in the production of cheese. Right, what is proteolysis? On page 109, proteolysis, another name for it, peptonization. This process, they say, the bacteria produce proteolytic enzymes which hydrolyze the milk proteins, primarily the caseins, into the components of amino acids. And the protein is solubilized, and the amino acids are decarboxylated and deaminated, resulting in an alkaline pH. In an alkaline pH, on page 110, they say, the litmus milk turns now a deep purple, because we know now that when litmus is becoming a pH above 8, it turns into a purple or a violet color. Right, what is litmus reduction? Fermentation, all fermentation processes. If you're making ginger beer, you're making pineapple beer, you're baking bread or something like that, and you wait for the dough to rise, that's anaerobic fermentation processes. All fermentation processes is anaerobic, in which biooxidations occur without the participation of oxygen. These oxidations are due to the removal of hydrogen atoms or electrons from the substrate. In order that such oxidations may occur, there must be available electron acceptors. In litmus milk, litmus acts as an acceptor, an electron acceptor, so that when it accepts the hydrogen or the electron from a substrate, it becomes reduced and it becomes white. That's what I said in the beginning to you. There's a nice oxidation reduction method, because this bluey grayish color under anaerobic conditions, yes, then it will become white. Okay. They say also that litmus reduction can also occur in litmus milk when bacteria rapidly consumes this oxygen during growth, and as the oxygen supply is depleted, facultative anaerobic bacteria can shift from a respiratory to a fermentative metabolism. Remember that facultative anaerobic bacteria can be under aerobic or anaerobic conditions. They can grow both ways. And they say that the shift from respiratory to fermentative and produce sufficient acid to form a curd. The curd hinders oxygen diffusion into the medium, resulting in a litmus milk tube filled with curd, having a pink top and a white bottom. Following are the type of reactions that may occur in this litmus milk. Now, lactose fermentation. They tell you what it is. What do you expect of proteolysis? What do you expect when there's litmus reduction? Ropiness is just what they mean. It's a slimy type of effect. If you take your inoculation loop and you put it in and you lift it up, you will see it is forming slime. Rennet coagulation is when the milk with a little acid formation action is due to a rennet-like enzyme. Okay, so what do I expect from you here? I want you to know about milk. I want you to know what is in the milk. I want you to know about litmus. How is litmus operating? I want you to know what is lactose fermentation. You must be able to explain it for me. Give me a reaction there. What is renin production? Why is renin production important to us? What is proteolysis? And tell us what is proteolysis all about. Litmus reduction. What is litmus reduction? And how will it look like? It will be a white color. Okay. All right, students. With this, I finished in all the chemical reactions in microbiology. It's the basic ones. There's a lot more of these ones. But I learned you the basic ones. Okay. And for each one of these, there's YouTube practical experiments that you can go and look. Unfortunately, we cannot do now practical. But if we could do practical, you could see all these nice reactions that the bacteria is causing in all these different chemicals. Okay, all of the best for you, and I will make another lecture for you guys. Good night.